Okay, this is a tutorial that relates to the Petite Sophisticates store case and that issue of will the store fall below break even? What's the probability of that given the estimate? So let's say that we have a prediction here, a prediction based on the regression that sales will be 200 at the store. And that comes also, that's just an estimate, and the regression tells you the error of the standard error of those kinds of predictions, which in this case is 22, we're going to say. And that's much like the standard deviation of those errors, basically. There's another name for that. And then there were 30 degrees of freedom here, let's suggest, from the regression. And let's just look at a regression. This is an example, but here is a regression. And where are these kind of numbers coming from? Okay, the standard error of the regression is right up here. Okay, standard error. And then down here are the degrees of freedom for each component, and the residual degrees of freedom are right here. So that's the one, we'd be using. Now, this is a different example, but that's where you get these kinds of numbers. And then this store had a break even, we're going to say, of 170. Okay? So now, let's get the probability that this store would have sales below break even. Well, basically what we're saying then is that we have a distribution here like this that is bell-shaped. You recall that from your Ole Miss 41 maybe. And that's t-distributed, and that's why you see t-tests and all that kind of. That estimate of the sales is t-distributed and has 200 as its most likely value. And you'll remember one other thing from statistics, that 1 sigma, 2 sigma, and 3 sigma represent 68, plus or minus 1 sigma, 68% of the distribution. So if we have plus or minus 1 sigma here like this, plus or minus 1 standard error, okay, that's going to be 68% of the whole distribution. 2 sigma is going to be 95%, and 3 sigma is going to be 99.7%. Do you remember this? Should remember that. But that's kind of like how many inches in a foot, how many feet in a yard, etc. for other kinds of things. So this is just fundamental knowledge about statistics. So we have 170 over here, which is our break even, and what we're really saying is, what's the probability that this 200, that we would get a draw over here that would be below the break even out here in this tail? Well, there's a function within Excel that's called t-dist for t-distribution, and it takes as arguments the t-statistic, t-stat, the degrees of freedom, and the number of tails involved. Okay, tails, I should call that T-A-I-L-S. And so what we're saying is, how many standard deviations over here is this? That's our t-stat, okay, which in this case is 200 minus 170, and up here over our 30, which is the standard error, over 30, and that is over 22, right? Over 22. Got the wrong number. Over 22, our standard error. And that is 30 over 22, which comes out to be about 1.364. Okay, so now we can plug that into our distribution, and we're going to get t distribution, and now we're plugging this into Excel as a function. And we're going to put 1.362, we're going to put 30 degrees of freedom, and, degrees of freedom 30, and one tail, because we're only looking over here at this one tail, not both tails. And when we do that, we get 0.019 or about 1.9% probability that this store would fall below break even, given all the parameters that we have here about the situation. Okay, hope that helps. And things get more interesting when you look at different situations. So hopefully this will, jog your memory. Thanks for watching.